This is big data. Now it's big data. It used to be a lot harder to anticipate that your technology would actually work at these presentations, but now it's gotten a lot easier. So I'm delighted to be here. I'm going to try to cover probably way too much material in a short amount of time, but can you hear me all right? How's that? Okay. So I'm going to talk about smart cities and big data in the context of urban planning. And I'm going to set the agenda up with three major themes. A quick synopsis of big urban data. This is something I think the other speakers have done as well, but to try to set context. I'm going to spend a few minutes provoking a little conversation around research questions and challenges that big data may or may not be helpful in addressing. And then I'm going to wander into the main body of the talk on how big data and data science is the term that I'll use for it more generally, can be leveraged to help urban planning in the context of urban simulation and visualization. So I'm going to start with a few visual examples to just jog our memory about what kinds of things we're talking about. This is a very common way of thinking about big data, is that we're mining all of these social media data, like geotagged Flickr posts in this case, and doing beautiful visualizations that also, in some cases, tell us something that's illuminating about patterns in a place. So here we're looking at inferring tourists and locals from patterns in the picture taking that was done by Eric Fisher. Here's another example that's really very close to some of the things we talked about today. Operational traffic management and the use of traffic sensors to guide that in real time. So these are all things that are either emerging from new sources of data like social media or the rapid proliferation of sensors that are well known to us and that act in real time and very short time frames. I'd like to think that some of the other kinds of data that maybe aren't so sexy anymore are actually also big data and also useful in the context of urban planning. So census data and lots of other administrative records that may be buried in various silos in different government organizations are also extremely valuable to thinking about the broader topic here of smart cities. You've also seen the proliferation of new kinds of mapping. In this case, Apple's ill-fated rollout of its 3D mapping product was one such initiative that tried to reconstruct three-dimensional realistic buildings from all kinds of remotely sensed data. And then someone's already mentioned this example, crowdsourcing of street data. The OpenStreetMap project. I assume most everyone here is familiar with that. So these are just to set the tone for some of the different kinds of data that we might be thinking about when we refer to big data. So now I'll provoke you a little bit with some questions and make sure that you're awake after lunch. So I'm going to ask some questions here and ask you to think about and give me some feedback about whether big data and data science more generally is useful in answering these questions or is readily usable for answering these questions. How traffic conditions are evolving in real time. That's pretty straightforward, right? I mean, we've already seen examples where navigation systems are taking sensor data and using it to make predictions and then rerouting vehicles in real time. What about which activity locations are most active and what times of the day they're active? We've seen examples of that in previous talks today as well, right? So taking information from where people are tweeting or other kinds of things like Foursquare check-ins. How about how do social groups cluster spatially? Is that something you can do with big data pretty easily? What do you think? Probably so. There's plenty of data that begins to tell us about that. What about which neighborhoods are gentrifying? Also positive? Right? You can probably find records that will give you inferences about that. What about why those neighborhoods are gentrifying? You'd have to think about that one a little bit harder, wouldn't you? When you think about gentrification or any neighborhood change process, there's a lot of complex dynamics that are playing into why those changes are actually occurring. And big data, in some of the ways that at least we think about it, may or may not be the most relevant tool to think about addressing that question. What about a little harder question, how alternative policies might impact gentrification in those neighborhoods? This is a counterfactual question. This is a planning question. Right? Now we want to think about not only how do things work and what are the complex forces that are contributing positive and negative feedback on those changes, but then if we intervene with one policy or a combination of policies, how will that change the outcomes? That gets much harder. Right? And then I'll throw the last one out, which is how can we design coordinated policies to more effectively mitigate and adapt to climate change? Now we've got something that's complex on so many scales it's hard to even fathom. And yet we need to answer questions like this. So the question is, how do we use big data? And I would say along with other tools, other ways of thinking to help us address these questions. I'm going to digress a little bit here also to provoke and stimulate some thinking and conversation about urban models as compared to big data. And I'm going to propose that there's a bit of a continuum and maybe a disconnect between at least traditional urban modeling, which in the past has been very theoretical, not very grounded in data. Examples being the monocentric model or some of the early agent-based models, very theory-driven, not very calibrated or validated to empirical data. Later on, we have models that were more driven by theory, but calibrated using what some people might refer to in this room as small data. The gravity model, for example, or the spatial input-output model. These use little bits of data, survey data and so forth, to estimate their parameters. And I would say that more recently, models have been informed by theory, but have started to make use of much larger urban data sets. Maybe these are medium data to get slightly towards larger data, and use much more empirical estimation methods. These are more blending of theory and data and empirical validation. And I would say that although some people have argued we don't really need theory, we just need data, I don't subscribe to that particular point of view. My own perspective on this is that really we have a richer terrain to work on these very complicated and very important problems if we hybridize the best of urban models with the best of big data, data science, again, more generally. We can use urban models to impose a modest degree of theoretical structure that enables counterfactual analyses, but then use big data to solve messy data problems, to help capture uncertainty, to help learn the structure and the parameters of models, and to enable adaptive learning that as we generate new waves of data can improve the models. And that's the direction I think I'm proposing. So I'm going to talk about that set of arguments in the context of some specific tools and methods that I've been involved in the development of for some time. The first of which is an urban simulation platform called UrbanSim. It's an open source platform. It's been on the web and under continuous development with quite a bit of funding from the National Science Foundation and lots of local governments that have used it. It's now become the most widely used land use modeling system by metropolitan planning organizations in the United States. And just in a nutshell, what it tries to do is capture cause and effect relationships that surround the real estate market and how governments intervene in real estate markets. So we're talking about real estate developers that are consuming raw land or redeveloping existing buildings. We're talking about governments that are regulating land, that are providing infrastructure and providing services and financing them in particular ways that influence the attractiveness of different sites and different locations. We're talking about households and businesses that are consuming floor space and housing in different locations and that interact in the labor market and the market for goods and services. All of these are tied together in positive and negative feedback loops that help us understand the real estate market at least in an abstract level. What we try to do in Urban Sim is actually simulate that at the agent level. So we get to the level of representing individual persons and households and the choices they're making about where to live, whether to rent or own, how many vehicles to own, and their travel behavior over the course of the day. We're similarly simulating businesses and their location choices and their growth and contraction and hiring and diminishing of employment, and in the short term, their goods and freight movement, logistics. We're simulating real estate markets and the processes that real estate developers go through. And then finally, we're simulating the effects of government policies on land use and transportation. We're not trying to predict what governments will do, but rather give them tools to analyze alternative policy packages. Now, all the individual behavior that's being simulated is being modeled with choice models. These are things that market researchers have been using to mine all those clicks on Amazon to figure out what book you should buy next. But in other venues, it's being used to predict, in this case, mode choices and other aspects of travel behavior or residential location choices or business location choices. Now, moving things from a research laboratory into the real world is a process of appropriation. And I heard various comments from earlier speakers, most notably about trust, that I think are highly relevant to this process of taking research from the laboratory and into practice. And I have gathered up some of the lessons, the hard lessons learned over many years of working with local governments to try to use these tools. These are some of the things that have come up most frequently as reservations or reasons to not trust or appropriate research. And so part of a long-term research agenda has been how to tackle each one of these bottlenecks. Part of that has involved also understanding the context of decision making and realizing that it's a political process. That at the end of the day, we may use models and scenarios that encompass different policy packages, but ultimately what we're trying to do is really inform debates among stakeholders that have very different perspectives about what's important, who wins, who loses, why that matters. And so this iterative circular process is my idealized version of how we can use models to try to inform a deliberative process and make it more responsive to evidence. So with some painful lessons learned, we have gotten to the point that Urban Sim is being used in quite a few metropolitan planning organizations across the United States, and it's being used increasingly in research projects and gradually into practical operational planning in various parts of other parts of the world. In Paris, there's a Grand Paris Express initiative, 36 or 37 billion euros of investment that is intended to reshape the patterns of development and transport in Paris. And Urban Sim is being used to help evaluate where the spatial impacts of that are likely to be and to inform the phasing and placement of some of that infrastructure. In the Bay Area in San Francisco, closer to home for me, it's being used to address climate change legislation and inform the development of policies both on transport and land use to try to mitigate climate change and reduce greenhouse gas emissions down to historic lows. So all of this starts with data, lots of data. Perhaps in some contexts this would not be considered big data, but I think as some people have put it previously, the complexity of the data actually is really one of the big bottlenecks here that makes it quite substantially challenging. So these are some of the data sets that we use, including crowdsourced data like OpenStreetMap, but lots of real estate related data as well, parcels and buildings, information on zoning and general plans, information on business establishments, and lots of planning inputs. What we try to do with that data is generate a graph that is the way we represent the connections among all these data elements. So we have individual jobs that are connected to businesses, persons connected to households, each of those located in buildings which are located on parcels, and those parcels are then tied to the street network and to the rest of the geography of the city in terms of its neighborhoods and districts and so forth. What that enables us to do is then compute accessibilities, the connectedness of all the elements in the city. And I'm going to play just a very short video here to show how we're doing some of that work. So this is showing visualizations of walk score types of accessibilities where we're changing the depth of the search along the local street map as we're making queries. And those queries could be anything from rents to how many coffee shops to complicated composites like walk score, but we can compute sort of any arbitrary combination of those we want. The software stack that we've been using is all based on open source tools, and the software itself is open source. Any of you that want to take an interest in it, you're welcome to go to the GitHub repository and to the documentation to explore it. One of the questions that came up today also already has been, how do we know whether the models are doing the right thing, whether the data science or the big data tools are on target? I'm going to walk through a few slides to at least put the project that we've been involved in that context. The first thing we do is look at the parameters of the model and the sensitivities of those parameters to know whether or not the variables are that are on the right-hand side of the model are influencing outcomes in a way that we would expect. So we can look at the counterpart of elasticities to do that. We can look at observed versus predicted values, and we can look at how a model innovation that we improvise or create changes the validity of the model. So in this case, we're comparing a workplace choice model using an aggregate model to one using a microsimulation model that has each individual person attached to an individual job, with each of those attached to individual buildings. And we can cut the root mean squared error in half by going to a microsimulation platform and improving the behavioral realism of the model. Another kind of validation that we do is longitudinal validation. This is hard, and it gets us back to the data problem as well as various other issues. In this case, we went back to 1980. Imagine recreating historical data as old as that, and then simulating forward in time and comparing what we observe to what we predicted. We learned a lot of hard lessons about that. We learned something about the spatial patterns in those errors as well, and the patterns of errors being different on the demographic side of the model versus the employment side of the model. Those have all informed further developments of the model system since then. We've also started working with statisticians to deal with uncertainty in a more principled way. And so working with Adrian Raftery and Hanna Shevchikova at the University of Washington, we applied a technique called Bayesian melding that allows us to repeatedly draw from uncertain inputs, assign weights to each draw of those inputs, and then come up with a calibrated model system that at the end of the day can tell you whether or not, when you simulate hundreds of times, you're capturing a 90% confidence interval that's actually realistic. So back to evaluation of results of simulations, we're finding that agencies that we work with are increasingly going to a multi-criteria kind of evaluation. They may use cost-benefit analysis as part of their toolkit, but they're often looking for a triple bottom line evaluation that goes across many different metrics. And this is a good example of that by the Puget Sound Regional Council that's used UrbanSim with their activity-based travel model to evaluate hundreds of transport projects and look at them on two dimensions, which I find really quite illuminating. One of them is a cost-benefit scale, and the other is whether they promote these multiple objectives. And I think that kind of nuanced thinking in evaluation of projects is actually quite forward-looking. And I think this is evidence of how to move forward with lots of data, but also good analysis in making better decisions. So I'm going to transition now to the last part of the talk, and this will be a little bit more visual, fortunately, no more math. in which we're starting to create platforms to do three-dimensional visualization and design and analytics. So I created a startup company a couple of years ago called Synthicity, and one of the main things we developed there is Urban Canvas. And so the first thing that we set it up to do was to allow us to run UrbanSim, which is as you've seen, a very mathematical and statistical tool that operates on lots of data, and actually get a glimpse of what's going on in those simulations. What are we simulating? And so what we have to do in that is timestamp all of the data and tag it to a scenario. When we run different scenarios, we then can see the data filtered by the date and by the scenario. So here we're looking at an upzone scenario in Denver and see that the buildings that are being simulated now in that particular upzoned area tend to be taller buildings. So this kind of way of representing data visually allows us to be much more proactive and I would say much more agile in exploring many different scenarios very quickly. Something that's very hard to do if you're running heavyweight simulations and don't have visual feedback of this sort. The next thing that we've done is start to use Urban Canvas as an incentive structure to promote open data and to promote shared data repositories that allow us to convince cities and counties and regional agencies to pool their data into common warehouses, very much the line of attack that COSP is taking in New York, but to try to do this with a very general platform that can be reused in lots of different places. And so in particular, unlike OpenStreetMap, we're trying to focus on the built environment to complement those things that OpenStreetMap is not doing. We approached the OpenStreetMap project initially to say, we really would like to extend the OpenStreetMap project to do these things, and they were unwelcoming. They've apparently found that things like parcel data generate all kinds of problems because of bulk uploading and the non-verifiability of parcel boundaries. You can't see them. And so we have some issues with government-generated records that ultimately the curators and maintainers of that data really need to be at the table and sharing that data. So I'm delighted to hear the minister and various other participants today talk about how you're building really smart national infrastructure here on shared data. So with that shared data, we can do all kinds of things. If we have it in a common platform, common backend platform, we're using PostGIS as the backend repository for this. It's very easy to navigate through that data, visualize it rapidly, do all kinds of data analytics on it, and then navigate to different parts of the world pretty easily. So we're starting out here in Denver. We're going to transition just momentarily here to a great place to go, Singapore. Unfortunately, I don't have any local data loaded because I don't think it was readily available to me. But I'm sure that's forthcoming, given that I heard all that discussion about open data. But I couldn't just go to the web and download it in preparation for this talk. So this is going to Paris, and then we just went to San Francisco. And because San Francisco and the Bay Area region have open data and have been willing to share it, we're able to load all that data up, do interactive indicators and heat maps, turn those into 3D representations with building envelopes, and really navigate the data in a very interactive way. So there are values to making the data readily available, and I encourage you to keep moving rapidly in that direction. The final comment that I want to make about this kind of direction of development is that I think we can make the process much more democratic, much more participatory by enabling local planners and community residents to actually generate proposals, generate projects, comment on them, and have that shared very interactively on the web, so that we can start to mine and leverage social media plus these kinds of interactive editing tools and visualization tools to really transform the way we engage the public. And I think that's a direction that's also fascinating and well worth looking into. So we're adding commenting functionality into this platform right now to further facilitate this. So with that, I think I'll conclude with two quick slides. One is just to reiterate and reinforce the message that I have been trying to deliver consistently in this talk, which is that big data or data science, I think, really would benefit from coupling with urban modeling, with design, with visualization, to change urban planning in very profound ways. I think it can make the process more informed by open and shared data, more participatory, more evidence-based, more agile, and more democratic. And I think these are laudable goals, and I think that I'm hearing many of these themes in the comments here in Singapore. And my very final thought is, as I have heard various people talk about training, I have taken that message to heart and started forcing our planning students to learn programming and to learn about open data and to learn to manipulate data from APIs and to scrape data from the web and to learn to make their own visualizations on the web. And they're starting to like it. They didn't like it at first, but they're starting to appreciate it now. So with that, I'll conclude and turn it back to you.